All right, good morning, good evening, good day, everyone. Welcome to Habitat Step 2. We'll be going through and taking Chef Habitat to the next level. A little bit about myself. My name is Graham Weldon. I'm an engineer for Rakuten for the last 8 years. I'm from Australia, but I'm based in Japan. And I'm probably most well known in the community as a Habitat Core Plans contributor. And one of the things I want you guys to take away from today is that for most things, I'm happy to help. So at the end of this presentation, there's a bunch of contact information. Jot that down, and if you need help with Habitat, I'm your human. So today we're going to run through a quick review of Habitat for those that need a summary. We're going to have a look at custom plans, deployment and organization, and some testing. So to kick things off, I have this Graham scale of Habitat adoption. And I joke, print this out, frame it, put it in a frame, put it in your office. Step 1, adoption of Habitat, is the usage of core plans and using the public builder. As you move on and get more complicated and a bit more less trivial, you start using custom plans, and that takes you on to step 2. The third step into that is to introduce testing. Now these are, over time, start to be a little bit interchangeable. You can start testing earlier. Maybe could be argued that you should start testing earlier. So I tend to now combine step 2 and 3 on this. And the fourth step is your movement to on-premise builder, moving away from the public builder. And that's more for larger deployments and enterprise installations, things that have restrictions on where data can flow. So today we're going to look at this combined step 2 and step 3 and how to level up your chef a little bit. Your chef Habitat a bit. So if you're new to Habitat, this will be talking about intermediate level things. We won't be touching the basics of how to use Habitat, but I'm going to give you a quick refresh on what it is and what we're looking at in terms of Habitat features and functionality. So the main features of Habitat that I look at and that I advertise to people and use to sell people on the Habitat idea are these 4 things. The packaging, to automate your application build and packaging, using tools and languages that are simple for everyone to understand. The network supervisor and cluster aware from step 1. So flipping the model of application and server deployment so that process supervision at its base level is network aware already. So there's no need to add things on top to start making cluster awareness a thing that you can have. Channels and promotion, so the simple system of using channels, essentially labels to attach to your packages for managing deployments. And the portability, the ability to deploy anywhere off a single artifact. All right, that's our quick review of the things that I like about Habitat and the things that sell it. So we'll start talking about packaging. Habitat plan is at the core of packaging your application and to build your artifact. And it contains, I think, 3 main things. A plan file, which defines how to build your plan, some configuration if it's a service, to how to run your service, and any other assets that are required to run your application. So for an example that we're going to run through, and there is a repository that I'll give you later that has all of these examples, we're going to run through a relatively simple caddy-based web server that's actually a very slightly cut down version of a production web server that I run. So for our basic web server, you would start with initializing. So have plan init my web server. I'm not going to run through these commands right now because we've got a repository that we'll dig into in a bit. Editing the plan.sh file for a caddy-based web server would look something like this. Essentially defining the package name, the origin, and the most important line, second from the bottom there, is the package dependencies, in this case, just core caddy. And the important takeaway from this is that something I like to reinforce is that we don't directly use core plans. We use them as dependencies, but we never run them directly. And that's an important thing as you start going from examples and initial introduction to Habitat into production usage, is to never directly run a core plan. Always wrap it. The next piece of the plan is about how to run the service and what exports and exposed ports need to be defined to allow this to run. So that you can see package service run defines the caddy command and specifies the configuration file to use for it. In the exports, it's saying it exports a HTTP port. Now, last piece of this is there is no build step because we are relying on a core plan that provides the binary for us already to use, so there's no build step. On the install step, we have a public directory which contains a index.html and a health check HTML file, and we just want to copy those into the package prefix when we install. So that is the full plan file. Once you've written the plan, have package build my web server will build the artifact and allow you to run it. And we'll run through these practical examples in a moment, but I'll run through the plans first. The next piece of this example that we're going to be working with through this is the load balancer, and HA proxy based load balancer is what we'll be using. So in a similar way, hab plan init my load balancer will get you an initial setup for your habitat plan. Editing the plan sh file looks very similar to the caddy web server. The difference here is package name, my load balancer, and second line from the bottom, package dependencies core/HA proxy. So again, we're not running the core plan directly. We're wrapping it in what's called two things, a wrapper plan or a configuration plan. So we depend on that for runtime, but we don't actually need to rebuild HA proxy. This is similar again to the web server. To run, it specifies HA proxy and a path to the configuration file, and it exports a port. What's different here is the load balancer needs to be aware of the web servers as backends. So here it's specifying at the bottom package binds, and it has a bind name of backend that needs an exported port. This will allow it to configure HA proxy to connect to any configured backend web servers. In this case, the build and install steps actually return nothing. There is no additional instructions to do. It's basically all controlled through configuration. Once you've done that, you can build the load balancer, and that will produce the artifact that you can use to run the load balancer. Okay. Quick test. Does this actually work? So as part of this, I want you to take away a fully functional version of all of this code that you can test locally in the studio and that you can test in a close to production cluster and see it all working and change it and mess with it as you like. So get the repository. If you're watching this now, use this URL bit.ly/ChefConf 2020. That will take you to a public repository that contains all of the code that I'm working through. Clone that and you'll be able to play with it yourself. So quick test. I'm going to do a setup here. The only thing that would be different for anyone that's running through this is the top line, export hab origin. That hab origin should be whatever origin you've got set up on Builder already. I managed to snag ChefConf 2020, so we're going to play with that one. So I'm going to export hab origin equals ChefConf 2020, and I'm going to set some Docker options so that when we run the load balancer, we can connect to it inside the studio. Export hab docker ops equals, so we want port 8090 and port 8091. Now these are configured for 8090 will be the web port that we just connect and browse the website. 8091 will be the administration statistics page. And then we enter the studio. Now, entering the studio is normally a little bit quicker than this. This is a little bit slow for one simple reason, and that is that I've customized the studio for this particular demonstration. And this is an interesting point. So you can see it says detected and loading .studio.rc, and this file exists in the repository. I just need to find my code. The studio.rc file specifies instructions that need to be run when the studio is started. So sorry, I need to increase the font size. I'm specifying to install nano, curl, and JQ static, all things that I need to run basic commands and get good functionality. And I'm also specifying the editor variable, which is useful to stop prompts from showing up from time to time. All right, so now the studio is up. We're going to run these quick steps, and these are short steps that I use. So build, and then the directory name of the plan. So in this case, it's my web server. We're then going to, once the build is finished, we're going to source the results last build.end file. The reason I do that is because I don't want to be typing out ChefConf 2020/my web server all the time. I source this results file, which contains all the information about the last build, and I'll show you that content in a second. And then we can use variables defined in that to do things like loading services or uploading artifacts. So if we build my web server, it's a relatively quick process. It downloads the core caddy artifact and then builds my package around it. You can see build report was placed here, source results last build.end. So if we have a look at results last build, you can see some useful information available about the last thing that was built successfully. If a failure did happen, and a secondary file will be created specifying what was the package that attempted to be built. Now, this is kind of interesting information, and as part of your journey of leveling up your habitat usage, build tools in and around these files and work a little bit beyond what you're given initially. So what I'm saying there is I'm a core plans contributor. So when I enter my core plans studio, which is slightly customized, there's a bunch of different things that happen. As you can see, every time I run a studio, I install Nano because I'm a Nano user, which I get a lot of flack for, but that's okay. But there's a couple of functions in here that I run to make my studio experience a little bit better and to make it more useful, particularly for long-running projects. There can be some useful ways to improve your experience. So build notify is a command that I've created. If I wanted to build something like JQ static, at the end of this, you can see there's a JSON output. I've created this build notify command to actually send a push notification to my phone, which will be hard to see, but I got a push notification to say that there was a core plans build failure in my studio. So there's some cool stuff that you can do around these files that are generated for you in the studio. So if we source this file, results last build, we can then do things like this: hab service load, and then pass in the package identifier. Hab service load package ident. Okay, so service was loaded successfully. If we check hab service status, yeah, we've got ChefConf 2020 my web server up and running. And do we have curl? Localhost 8080, my habitat-based caddy web server. So that's working. The next quick test is to do the same thing for the load balancer. So we'll do the same commands with my load balancer placed in there. These are very quick to build because they are configuration plans. They basically only add configuration to an already built binary artifact. So once that's been built, we can again source the last build file, and then running this is going to be a little bit different. Hab service load the package ident, but for HA proxy, for our load balancer to work, it needs to bind to a backend. So hab service load the package ident of the last build and bind the backend to my web server.default. Okay, so give it a second and you can see my load balancer is now up, and we can curl that endpoint. 8090 is via the load balancer and showing the caddy response. And I think 8091 is going to give us the administrative interface. That's not so good to look at from that view. So let's have a quick look from our browser. So 8090 will give us the caddy web server response, and 8091 will give us the HA proxy administrative interface. And we can see in very, very small text, we can see host 0. So our initial host web server backend is there. So that was very, very simple to get up and running with binds, with the service discovery. We've done a couple of different things that I think through your initial introduction to Habitat you may not have used, and that is the service binding. We've done a configuration plan. The builds are extremely fast. And we've got a couple of different dependent services running locally in the studio with very, very little effort. So this is what basically what we saw in the administrative view. The result of that packaging, and we're all talking about packaging right now, is a single artifact for each package. The web server is one, the load balancer is another. They're completely portable. So this artifact can run anywhere. It's packaged in a Habitat artifact format that allows you to export it for different systems. You can export it as a tarball, export it to Docker, Cloud Foundry. You can build your own exporters as well. This artifact can also be uploaded to Builder, and that's the route that we're going to take as we run through running this on a production-like cluster. So with that, we're already on to step 3 of the scale of Habitat adoption, arguably step 4 as well, right? So we're using custom plans. We are relying on core plans, but only as dependencies. Right, the next thing I want to talk about is the network supervisor. We're going to talk about deploying a production style cluster, how that works and how it's set up. So this starts with a Bastion node. This is my preferred approach. There are different ways to do it. Bastion node is, in my clusters, a separate set of nodes that is specifically designed for being a contact point for supervisor connections and for constructing a cluster. They don't run anything else. Often in a production deployment, I will have what I call an operations node that is purely for application-specific operations that need to be done. It's just a Linux host that you can use and store particular scripts and commands on that you need to help run that system or inspect that system, and I'll use those as Bastion nodes. Once you've got your Bastion nodes up, you can start up the servers designated for web servers, load balancers, and any other nodes, and tell them to peer with those Bastion nodes, and that will start the construction of your cluster. Once they've pointed to the Bastion nodes, they will actually be able to discover each other. So when bootstrapping your cluster and going to production and becoming more reliable with your setup, the best advice is to have at least 3 nodes for production. For testing and for staging, 1 is okay. Connect all your application servers to the Bastion nodes with a Bastion file or by specifying the peers in your supervisor startup commands. I like to use the file because I can have Terraform build that out, and the file exists on disks. It's on disk. It's persistent, but I automate that file creation wherever possible. Like I say, Terraform can create that Bastion file for you and place it somewhere in the hab directory so that it's obvious and easy to find. Use a Bastion cluster per data center. If you're reaching out beyond data centers and your deployment is becoming quite large, make sure that you've got a bastion per data center or per availability zone. It depends on your intentions and your deployment structure, but that is my recommendation. So the 3 steps to a simple habitat cluster that is successful. Step 1, make sure that your bastion nodes are in place and that they are either well-known or easily discoverable. So they should either have well-known IP addresses or they should be guaranteed resolvable on a existing DNS system. The Vagrant example that we will go through has a known IP for the bastion node, and that's exactly how it works in my production setup. Across all of our data centers, I have known IP addresses that I can use as bastion nodes for supervisor cluster construction. Step 2, start your habitat supervisors on the application servers and peer them with the bastion nodes. They don't have to immediately run your applications, but prepare them to run by peering them with the bastion nodes. And the 3rd step is simply deploy your applications. Okay. I was only made aware of this relatively recently, but the Terraform Habitat Provisioner is something I haven't looked into myself beyond looking at the documentation. So try the Terraform Habitat Provisioner. It actually looks really cool, and it does basically all the steps that are included in the repository I've written in a Terraform-centric way. If I could have changed the demo repository to use Terraform, I would have, but I think it's more relevant to external deployments, AWS, Azure, on-premise stuff. If you're on VMware or OpenStack or something, you can use the Habitat Provisioner to start your bastions and peer them, peer your supervisors with that bastion cluster. Okay, so I've got a cluster that I prepared earlier. Now, there's no magic behind this. This is simply starting up the Vagrant cluster that I have here. Takes about 30 minutes to get all the VMs up and running because it won't run in parallel. So you guys can actually run this same cluster from the repository that I linked earlier. So I want to take a quick look into what this network supervisor does and what it means. So we're in the directory here of the repository, and we can check the Vagrant status. What we should see is a master node, which is the bastion node, and then application nodes for 3 web servers and 2 load balancers. Okay, so we see master node, 3 web servers, 2 load balancers, and we can SSH into any one of those. So web 1 is what we'll use. What I want you to do here is become comfortable with looking into things like the butterfly endpoint on the supervisor. So with the network supervisor, you get a whole bunch of benefits. It's network aware. It's got a management interface. You can inspect it and see what is going on. So this is a bit of a mess of JSON, but this is the response you get back when you're looking at the butterfly endpoint. If we pass that through something like JQ, we don't have JQ. Okay, that's okay. Hab package install bin link core JQ static. All right, now we have JQ. You can see here that we have a bunch of information about nodes that are up. And this is specifically what I'm interested in looking at here. Here are the members of this cluster of supervisors. We can see each of their IP addresses, we can see their node IDs, and we can see their status. So you can start doing some pretty cool stuff with this, like let's just look at the members. All right, so that's just a list of the members. All right, so that's what we did there. You can see how consuming this information in your own custom web interface would be extremely useful to do things like supervisor status visualization to get an overall view of your cluster. And then as soon as I start playing with JQ, and I don't know if anyone else is like this, but as soon as I start playing with JQ, I start getting crazy with the expressions and doing all kinds of silly things with it. All right, so loading services. I want to introduce to you, and starting with the web server, channels and strategies. So in testing, we do something like have service load and then specify the origin and the package that you want to load. Now, we did this, except we put in the package ident variable to specify the last build ident. In production, you would most likely do something like this to specify the origin and the package, but also the channel to work off and the strategy to use. So in this case, I'm telling the web server to subscribe to the unstable channel, which people might argue is not a good idea, but it depends on how packages get into that unstable channel. Unstable is the default channel, by the way. When you upload a package to Builder, it goes by default into the unstable channel. The strategy here is at once, so all the web servers can update at once. There is no coordination required for them to update. On the load balancer side, we did this in the studio. We did have service load, my load balancer, and then did a bind to the backend, my web server. In production, we do a similar thing, but like the web server, specify the channel and the strategy when we're loading it. In this case, I'm saying that the channel is stable, not unstable, and the strategy is at once. So again, it can load all load balancers with updates at the same time. The reason I've got these on separate channels is just for demonstration purposes, to show that a channel is basically a label associated with a build, with an artifact. Unstable is the default channel, and stable is the convention-based stable promotion, but these are arbitrary channel names. They can be whatever you want. Now, we've got this cluster up and running on Vagrant, so I want to take an opportunity to look further into the cluster to see what we can do with that information. Let's have a look into the census endpoint. So the last one we looked at over here was the butterfly endpoint. So if we come back here, the census, again, you can see there's a lot of information here. If we clean this up, we can see some information here about services that are running. So here is a particular supervisor. Here's its member ID and package information about the package that it's running. So this is running the My Web Server package. We can see the full ident and then status information about that particular system. Is it alive? Is it departed? Any configuration that is relevant? And again, so this is a great way to look into the status of the cluster, what's running, and what is actually going on with your applications. Okay, channels and promotion. Now, we've been playing around in a studio and in a demonstration cluster. What I haven't shown you is uploading packages and how to work with those. So get ready for upload, enter our studio. So we're already in a studio here. We already have some stuff built. But what we're going to do again is build the web server and upload the package to Builder. Build web server is very, very quick to build. Source that results last build file and then have package upload. And I'm using these variables again. So that uploaded the My Web Server. Next thing we want to do is build my load balancer. Super quick to build. And upload that artifact. Okay, so we're just using the public builder here. Check builder. What channels are the new packages on? So going on to the public builder here, we can see on ChefConf 2020, we've got my load balancer and my web server. If we look at my web server, the latest one was built just now, and excuse me, by default, it is on the unstable channel. The builder interface gives you the ability to, with a click, promote to the stable channel. But remember, these are arbitrary names. The load balancer, same thing. It's on the unstable channel. We could promote it to the stable channel. So this is the state that we see things in at the moment. We've got my web server at the top on the unstable channel with a particular build that we just did. We've got my load balancer at the bottom, again on the unstable channel with the build that we just did. Now, when we ran our services, and I'll step back here a little bit, you can see that we had the load balancer listening to the unstable channel, the web server listening to the unstable channel, the load balancer is listening to stable. So once the packages are uploaded, we'll need to promote the load balancer to the stable channel for it to be updated on supervisors that are actually running that package. So how do we do that? Once we've built and we've uploaded one, we can use the web interface is one way to do it, which I'll show you just now actually. So on the load balancer, we could just click promote to stable. Yes, promote. That is now on the stable channel. That is one way to do it. Another way to do it is when you are building, and we'll run through this build again, build the load balancer, get the last build, upload the artifact. We can also say hab package promote that package ident to stable. And now that has been promoted to the stable channel. As I keep saying, there are arbitrary channels. They can be any name that you like. So if you have any other channels that you want to promote these onto, that can be applied to those same packages as well, using the same method, changing the name at the end. Instead of stable, put your name. And a quick note on portability. The artifact that, excuse me, the artifact that is produced is capable of exporting into practically any format. By default, there are exporters there for Docker, Tarball, there's Mesos, Cloud Foundry, there's a whole bunch of different formats, but you're actually able to write your own exporters as well. You could potentially extend one of the existing ones to perhaps change the way that the Docker exporter works to match your specific needs. So in terms of portability, what we've seen running right now is I've been using the Habitat Studio, which I'm on a Mac, so it's running on Docker. If you're running on Linux, it'll run on the system. It'll be a Linux-based studio. Those same artifacts run in the same way in these different environments. In the cluster example that I've got running on Vagrant, it's Linux and it's running them basically the same result that a tarball export would do, but it's pulling down the artifact and running it that way. So the same thing is able to run in these different environments from the same artifact. Operating system independent, so you basically just need a Linux kernel of the right version. Everything else ships with your artifact. Okay, now on to the next piece, which is something that's really, really important to me, and I think something that is not very well adopted, at least in the circles that I've seen, is testing. The heading's wrong here, but just ignore it. So there are various methods of testing, but make sure you do testing in some way and use the mechanism that works best for you. Excuse me. The most common methods or recommended methods out there at the moment is to either use inspec or to use something like bats or pats, depending on if you're Linux or Windows. I'll be talking Linux examples here. Inspec is great. It's Ruby based and it's flexible and easy to read and share, and it may fit in with your existing compliance workflow. It's relatively large in terms of its dependencies, and that's why I'm not using it, and that is why initially we didn't choose inspec for Habitat core plans testing, for example. On the bats and bash side, it's easy to understand. Everyone already knows bash, I think. Minimal dependencies, it runs everywhere, and it's very lightweight. So there are testing examples, and these are great examples that I still refer to today. Some of them I've written, other people have contributed as well, but I will always look to these particular examples for how to do testing. If I need a refresher on what's a good structure for testing services or for testing binary only builds, I'll look into the core plans. Now, these are contributed by a whole bunch of different people in the community. They are perfect examples of how to thoroughly test something that is going to be distributed to a lot of people. So grab those as a good example for writing your own tests. I'll run you through test examples, and there are test examples included in the repository as well. Now, tests, as I've moved from a trivial setup to a production setup to a what I'm working on at the moment for my job is a global system that is built on Habitat technology. It's important to make sure that any build that gets uploaded to our builder, to our depot, is fully tested. My strategy or my approach, my philosophy is that I want every artifact that is on builder to be a fully tested and functional, ready to run artifact. That's my preferred approach. So include the testing as part of your pipeline. And this is what my pipeline looks like. The commit and push workflow for developers doesn't change. It's simple, it's predictable, it's familiar. As soon as you start getting into CI, and this is, I think, the only point that should be allowed to upload to your builder, it should run the build as soon as commits are pushed, and that's for all branches, including master, intermediary merges. Do the build. Once the build is successful, proceed on to test. And if the tests are successful, automatically upload that to builder, ready to deploy if anyone's listening to unstable, or ready to promote. So any commit that is pushed will kick off a build. It'll run the test, and you'll be fully aware of how that artifact behaves. If tests pass, automatically upload, and you have the option here that if you are confident in your tests, you can actually automatically promote to whatever channel is appropriate to you as well. The most important part here is that the build and test happen automatically, and when successful, automatically upload. That's an extremely useful process to have in place, and it's extremely quick as well on the Habitat build side. Now, not everyone likes an automatic promotion. I've found in my work that certain types of people like to have the power of pressing the go live button. So using all the techniques that I've shown you in terms of poking in and around the butterfly and census endpoints, as well as here digging into the builder API, we've built a custom release management tool that shows in staging, everything is automatically deployed. Any build that is successful, passes tests, and is uploaded to builder is automatically deployed to staging. No questions. If you want to go to production, we've got a simple one-click promote button that allows you to promote the latest build running on staging into the production environment. On the back end, all this is doing is promoting from unstable to stable. That click button is just calling the builder API. So the test output, for the tests, and we'll run through them in a moment. Basically, the output is CI friendly. This is the BATS approach. When we run, we can actually run, I think, these in the studio here. Hab package build, build my web server. Now this is a build, same as running build my web server inside the studio, but this is external to the studio. You can do the same thing on the outside of the studio. So that has done a build and is successful. We can still source the results last build, and then we can say hab package hab studio run my web server tests test.sh, and these need the package ident. So this is using the studio to run the test against a specified package identifier. This allows, the way this happens is passing in the identifier allows you to specify a current build, which I'm almost always doing, or a previous build. Let's try that again. So I could run a test, say run newer tests that have been developed against a previous build to see if that is still successful. Passing the identifier allows it to be a little bit more flexible in its testing. All right, and of course, I'm having problems with memory allocation while I'm doing streaming and running a cluster as well. So running this will give you an output similar to this. So I've got 4 basic tests. Can I run a basic command? Does the configuration validate? Does the service run? And is it listening? And these tests can go to all kinds of different levels. I like to start at the basics. So can I run the command that I need to run the service with? Config validation is the next one if it's available. Then can I run the service? And that service running can be a bunch of different tests, like check for process names, check the habitat supervisor to see if it's there and it's up. Then moving on to, for network services, is it listening on the ports I expect it to listen? That's a very simple test, but going beyond that, as your service matures, you probably want to check additional things. So example of a service that I'm running at the moment, we don't just check that it's listening on the right port. We actually check to make sure that we're getting a HTTP response from that port for a particular web service that we're running. What we also check is the response, the HTTP return code, status code. We also check the content to make sure it contains certain things that it should contain. And we check the protocol. Is it HTTP 1 or is it HTTP 2? All of these things are defined as being successful. If those pass, that service is successful. Protocol specific checks are really important if you have multiple things running on the same system and a mix of different configurations. So if you're testing a MySQL server, for example, you probably want to check that when you connect to that port, not only is it listening, but it is responding with the MySQL protocol. It's not responding with Redis or a web server, right? You want to make sure that when you run that, you're getting exactly what you expect back. The return code from running these tests is a simple 0 or a 1. So you can integrate this very easily into whatever CI pipeline you've got. I've got this running on Jenkins, Circle CI, and GitHub Actions, just trialing all the systems. Currently going with Circle CI, but in the case of a failure, you'll see it gives you some context as to where the failure happens. And this is BATS again. This is just plain old BATS. And the response code will be 1. So you can use that in your CI to prevent uploads, to take further action, send notifications, or whatever is relevant for your particular builds. All right, so let's talk about writing tests. Okay, in the repository that I gave you a link to, and there is another link at the end if you missed that. If we look at my web server, we've got a tests directory. We've got a test.sh file. Okay, this test sh file is rather long in terms of what its functionality is, but it's a common format that I almost copy and paste between different test files. So to start off with, setting options for the testing. This command here is something I'll place in almost every bash file, every shell file I have. It's for help. So this says if there is no arguments for this, output the usage, which is any line that starts with #/. So it'll just output that there. The important stuff is here. So when we get into the studio as part of the testing, install bats because we're going to use bats to run our tests. Then I have some dependencies for the tests. I have netstat and curl. I then install the package that we're currently testing. And I use a helper function to load the service. This is basically hab service load, but it makes sure that the supervisor is running and gives it some time to start as well. Once that's done, it runs these bats tests, and this is where the meat of the tests are. These are just bash functions that are called and allow you to do things like inspect the status, check the return, and for example, down here on listening port 8080, we check the netstat output, check for a particular process, and make sure that that particular process is listening on port 8080. So this takes the test of is the server listening on port 8080 beyond it a little bit further to make sure that the correct process is listening on port 8080. So these examples and the load balancer examples as well are included in the repository for you to have a play with. The most common shortcut for testing is, and this is what I'll be doing when I'm doing local development to iterate fast, I'll build a particular package and I'll source and inject these variables, package name and package ident, to do a quick test. I think if you type SO on my regular command line, I think it comes up with this command all in one. That's how often I use it. So if you include that testing as part of your pipeline, even if you're using the public builder, make sure that you're using custom plans. The only usage of core plans that you have should be a dependency of your configuration plan or wrapper plans. You're into that merge step 2, step 3 of habitat usage. The next big step on from that is system configuration and changes to get yourself with up and running with a on-premise builder, which is that sort of last step of full production internalized habitat usage. All right, so a quick recap and some major points. Core plans, consume them, absolutely consume them. Take advantage of the hard work that has gone into building very stable and very well tested plans, binaries and services. Don't use them directly, don't run them directly. Absolutely wrap them and have them as dependencies for your own plans. Very, very important point. The supervisor cluster. Building a habitat supervisor cluster is really simple. Take a look at the Git repository I've got and try the Terraform provisioner. Once you've got yourself up and running with a cluster that has service information available without any extra effort, you'll wonder why you've not been doing this all along. Service discovery. Use the service ring to discover and bind services. There are a bunch of different techniques to inject services into the Habitat service ring. There are also ways to bridge it with external systems like console, so you can actually work both ways. But the Habitat service ring is an excellent way to do service discovery if you're starting to do a fully Habitat-based environment. And test everything. Testing is very easy. It's tricky to get started, I think, but once you've got started, it's difficult, I think, to know when to stop. And I think that's my problem in some cases. If you've got testing down, it will give you the confidence for package promotion. You'll know that And like I say, go through those steps of different levels of testing. You'll know that the service is running, it's listening on the right port, it's talking the right protocol, it's the right version of the right protocol, and even test the failure cases where you send a patch request to a web server, it should respond with this particular error code because you don't support that method. Test the failure cases as well. The more you have in there, the more confident you will be in being able to press that promote button or potentially automate the promotion of those packages. Have a look into the core plans repository. There are thousands of examples to get you started on testing, and they are well curated and reviewed examples. Break things, and I think this is just as important as testing. Have a look into what Habitat is providing you. Curl those endpoints. Have a look, have a play, scrape the data, visualize it in a way that makes useful sense to you. There are a couple of tools that allow you to do this. So something that I'm not using personally, but I saw this and was just super impressed with what's going on. So Chef Automate has the applications tab now to visualize what's going on in Habitat. Definitely have a look into that. Quick note on something that I built is a very, very ugly looking census viewer. It allows you to inspect habitat and biome endpoints to look at census data to see what service groups are available, what services are running in those service groups, and a list of all the members running those services, and look at the critical information about that. So thank you very much. That's my next level talk on Habitat. Here's some contact information if you want to get in touch with me. And the presentation repository is at the bottom if you want to check that out. It's a fully functional cluster that you can play with and break. Please break. Thank you very much.
Wow. I need a nap after that. That was a lot, dude. Holy cow. Yeah, if anybody has any questions, please use the Q&A panel. We'll read them out and answer what's going on there. A lot of stuff in here that I hadn't seen before. I haven't been actively doing a lot of Hab stuff. I've mostly been working with Inspect, but like the Studio RC stuff and like some of those other things seem to make the whole workflow a whole lot nicer.
Oh yeah. One of the, I think the most useful pieces for me is like my tooling is a lot different to a lot of other people in that I prefer Nano as an editor, for example, right? I use certain tools for notifications, like my Studio RC, particularly for core plans contributions, is customized to make me more productive. And it's like a bash RC, right? But it's
Yeah.
for when you enter the studio. So you can customize it in a lot of ways that you're probably already customizing your shells.
Yeah, absolutely, man. That's super cool. The testing stuff too is super neat. Like I definitely have a soft spot for bats. Like that's
Mhm.
uh, that's great stuff there to throw into whatever. So interesting to see that pulling in uh, for testing some of this stuff. So like, yeah, while you were talking about it, I was like snooping around on some of the core plans to see what else is in there. That's super interesting for that.
The core plans is an interesting evolution of the testing. Like we went through some pretty heavy heated arguments about what we should use to test and how we should test, and it's been through a couple of iterations, and that's I've been involved in the whole process, and that's why like I love taking the things that we have settled on in core plans and putting them into production systems, because it gives me that, like I don't deploy to staging systems anymore. That's all auto deployed because all my testing is in place and I trust that testing. And doing that is a relatively simple thing. Um, I look forward to the day where I can sit back on the beach and just drink beers while my production systems are updating themselves one day.
One day, yeah. One day when you're allowed back on the beach, right? But
Yeah,
like
right.
the rest of the process is in pretty good shape for where it is. So no, that's super awesome. All right. Does anybody else have any other questions out there? Anything? I think this will be one that people will be watching over and over again as a reference as they get their Habitat game leveled up. So thanks everybody for coming. Stay safe, wash your hands. Thanks, Graham, for a great presentation.
No problem.